Hi, welcome to this lesson on statistics regression. Let's have a look at symmetric versus non-symmetric data. Okay, so often we can visualize data in many ways, such as histograms, bar charts, pie charts, continuous curves, and so on. Certain data points will illustrate either what we call a symmetrical type of graph, so that's even looking, so it's symmetrical on both sides of the mean, or a non-symmetrical graph, which is usually skewed to the left or skewed to the right of the mean. Okay, so here is a diagrammatic visual tool to show you what data looks like when it is skewed either to the left or to the right, and when it is symmetrical. Okay, so often whenever we take data points from anywhere in the real world, they will fit under one of these three types of categories for the graph of that data. Okay, so here we have a skew to the right or positively skewed graph. So essentially this is a histogram version. If we're looking at a continuous curve, the curve might look something like this, for example. And you can see that majority of the values are skewed to the right here. And you can see on the box and whisker plot here, we can see that again, this is more skewed to the right. There's more space here for the latter 50% of your data. We also have an algebraic way of determining whether a graph is skewed to the right or left or symmetrical, and that is if you can work out the mean value and you can work out the median, which is your quartile 2. If your mean value is greater than your quartile 2 value, then we have a positively skewed or skewed to the right set of data. Okay, similarly for symmetrical data, this is data that is usually, now if I draw a continuous curve over here, that's going to look something like this. And you can see it's almost like a perfect kind of bell curve. And this is a very special type of curve in mathematics. This bell curve, we usually call it a normal distribution. The normal distribution pops up everywhere in statistics. It is the most fundamental type of probability and statistical distribution that you will study if you go further on into any type of scientific field. Okay, it will always pop up. Okay, so with symmetric data, you have again an algebraic representation, and that your mean and your quartile value are almost the same value. So we have a symmetrical set of data in that case. And then on the other end of the spectrum, you can see a lot of data is appearing under that left-hand side, and then a few data points on the right-hand side. So again, here in the box and whisker plot, your mean value, again, all the value to the left, so the first 50% of your data occupies the most amount of data points. And again, your mean here, if you calculate it algebraically, will be less than your quartile 2 value, your median. All right, so that is the difference between symmetrical and non-symmetrical data. Awesome. I'll see you in the next one.